Cool, XTDB 2, yay. Let's see. What I was saying before we started recording was when we were going through XTDB 1, there was several notebooks, but they were on Nextjournal, and so we could actually execute them live. And the the playground stuff now, it uses Clerk, so it's got like a static rendering of the code. So when you get to the where's the exercises, we can't actually try them out. We have to, I mean, we could just look at the solutions, but it's just Clojure code. So I was trying to execute it before we started, and ran into some problems because I think that it was made. There's been some API changes, and so the thing that I came across was right here when you submit the transactions. There used to be an XT put function that would like make the transaction for you, and they just went to using data like this. So
yeah, it changed the SQL implementation as well.
Oh, really?
Yeah, they used to have ops for doing SQL and providing arguments, and so you used to have a sort of a DSL for that, and they've decided to go just for vectors. And James Henderson of the XT team put a PR up against my next JDBC XT lib to change all of that and get it working again, which I thought was very nice of him.
That's cool. So are you able to keep pace with the latest in that driver?
I had missed that change because I had stopped paying attention to XT2 for a while. So it was nice that he was putting in a PR for me.
That's very cool. Absolutely. Cool. So I did this beforehand, but I'll do it again for the recording. One of the things that they talk about in this is you can use Clerk to run it, but I just want to evaluate it in the REPL. So I'm just going to evaluate certain forms and not evaluate the whole thing because it'll actually run all the queries and everything because everything is in here. Clerk is smart about not evaluating things twice, but Clojure is more. It will just go ahead and evaluate everything again. So let me restart a plain REPL so we can go and evaluate that. The namespace. And then I'm skipping over the whole Clerk thing. Get to this. This is an in-process ephemeral XTDB server. Start that. And that takes a little while. I think XTDB works as an in-process server and then also as an HTTP server. Or like you can run it like you would Postgres, like it's over there.
Yeah, it does.
But there's no like the XTDB 1 was like you had an in-process and an in-process library that would like keep a cache locally. I think kind of more like the Atomic does. But then XTDB
yeah, I believe they had like RocksDB and they were like taking the Kafka log and like indexing it in RocksDB locally.
Oh yeah, so there was a local thing you were querying, a local.
Yeah.
And when you stood up a node, it had to rebuild the index. So they've essentially done away with the local index, so it doesn't have to rebuild that. So it looks more like a traditional client server database setup.
So it's a little more familiar, but it doesn't have the nice fast speed of all your data's local.
I think they still have the local server, just like that you currently can query it over HTTP, so you can kind of have a longer running server.
Right, yeah, you can run it in a container, and it's accessible as an HTTP service. The one that they stand up in Amazon has Kafka and all sorts of bits and pieces in there. That's just like a huge number of moving parts. Or you can have the sort of the transient in process node to play around with. So you can do your sort of dev test in memory and then work on either a local node or fully cloud node.
I think what
Is
they
it-
changed is like the way they store this index. So it's similar to Datomic right now, where it's like you don't have to download everything. You can only download parts of it. And with arrow files, they just kind of like you don't really need to rebuild an index. You just read from those files. And arrow files,
there-
you know, they're super fast. Like I was doing some project with like big arrow files, a few gigabytes, and use DuckDB or something like that to read from them. Like you just read them from disk, and like all the queries is way below 1 second, and it was quite complex queries. So as long as you have properly sorted data, it's really, really fast.
Is there an XTDB 2 posted offering? Is that what you were talking about, Sean?
No, what they've got is there's a Docker version
Oh,
you
okay.
can just spin up that is essentially the HTTP version on a particular port. Or there's the full AWS stuff. They've got all the recipes for building an AWS cluster.
Oh, okay. Gotcha.
So did
Cool.
they drop the idea of starting as a hosted solution, like kind of XTDB cloud? Or
I can't remember.
is it still the
that-
plan?
I don't know. You'd have to look in the forums to see what they've said about it.
Yeah.
Because I think they were like, oh yeah, we will launch the cloud version before the end of previous year, and I haven't heard anything about that since.
All right. I'm just going to evaluate the data. Persons, XTDB, XTID, nice namespace keys. Many ID types are supported, including UIDs. Yeah.
Well, I feel like the main change, we discussed it last time, that now you kind of have a notion of tables.
Yeah.
So this is a big change from XTDB 1. And
Interesting because like movie, like there's a nested movie cast which has IDs in it. So like in order to do like a many to one relationship, instead of having a separate database table for that, like it's just built into the, like it can handle one level of nesting, I think, of IDs, which is pretty cool. Transact
wonder
those
if you
in.
can enforce it. Like, will it, if you just put a random ID there, will it throw an error, or like just silently store it?
Well, they're just numbers, so you actually would have
Yeah.
to do a join on them. And
Yeah, I'm just
yeah.
like, if they have a function that will check if that the number exists on the other end.
Yeah. We can now execute a query.
I guess
Yes,
they support the same like as Datomic, where you can just put some, ID that will be filled in during saving the data. Kind of if you want to save, actor and the movie together. So you kind of put
it'll fill in. Yeah,
like
as long as it's like DB -1 and DB -1, it'll fill it in or whatever.
Yeah.
I
guess they
that.
must support that.
Yeah, I wonder if they have the concept of foreign key checks. That would be because like in a regular Postgres database, you can say, hey, here's actor ID number 2, and there's a movie with actor ID number 5, and there can be no actor with that ID, and the database is fine with it. Of course, when you join, it wouldn't show anything, but that's
Yep.
it's on you. So this is from movies, movie title. What else is there? Movie, what if we do movie cast? If that does anything. Okay. So it's it feels a lot more like a version of Honey SQL, but it doesn't convert it into a SQL query. It's like it's using the data directly, or the structure directly. So let's see. So they make a queue function, makes it easy to execute queries. All right. Is it big enough for everyone?
Yep.
Okay. You can also use the same queue API to run SQL queries by passing in a raw string. Oh, wow. Really? That seems cool. Movies.movie.
There's a mapping from the slash to a dollar. So
Oh, I
the
see.
table is movies, and then it's movie/title. So it'll be movies dot
Oh,
yeah,
dollar year.
dollar. Yeah.
I wonder why do you need to have movies duplicated everywhere if you put from movies?
Yeah, that's personal preference in terms of the qualified IDs in the data that you save. You don't have to save qualified data. But it does get a little weird once you've got tables and you've got qualified names in there.
Yeah, but
Yeah.
like qualified name is like movie year, right? And I don't know. It's probably like if you have the same, but can you have the same name of the field in different tables or no?
Yeah.
Yeah. Okay.
Because it underneath the hood, could store them in 2 different columns because they're namespace sorted by the table.
Yeah.
I'm guessing.
And it will, if you pull back multiple columns with the same name on multiple tables in a join, you will, I believe, if I remember rightly, it will automatically sort of add like _2, _3.
Oh, interesting.
But you won't know
Like
which
if you
one's
have,
which. So you'd really want
if you,
to use an alias and say,
yeah,
something else year as whatever.
yeah, interesting. Like a name, an artist name, or a actor name and a movie name.
Yeah,
I
if you
see.
weren't using qualified keywords for the keys, then you'd want to use aliases to make them unique, which is
Yeah,
much
that
the
makes
same
sense.
as doing that with SQL databases and NextJDBC.
Cool. Okay, so we can run queries now. Hey, there's this thing called extensible data notation. We should study that. That sounds cool. Let's see. Let's get our first query. Finds all the movie titles and this time discuss how it works. Composable operators optionally combined with a pipeline. Since we only have from, which is a source operator, retrieves a relation from a table stored in XTDB. First argument takes is the keyword name of the table, movies, and the operator then takes the vector containing the columns return. In this case, just listing the plain symbol movie/title, which corresponds to movie in our document. Columns are inserted as keywords, but throughout queries are only accessible via bindings with their corresponding symbols. Columns and logical variables use symbols interchangeably. Okay. Example database we're using contains movies that mostly, but not exclusively, from the 1980s. You'll find the information about movie titles, etc. As the tutorial advances, we'll learn more about the contents of the database and how it's organized. All right, so here's our schema. So this is just like by convention. We could actually just put anything in those tables, I'm guessing. It's not like enforced like it would be, because Datomic enforces the schema, right?
Yeah, you have to declare your schema to Datomic before you can actually store the items
Put
in it.
something in.
Whereas
right.
with this, it's you can put anything you want because it's document based and there's no schema.
Yeah.
So the only schema is that it's got to have an XTID in every document. And you've got to have a table name associated with it. That's about the extent of it.
Anything goes. All right, so if we wish to find the IDs of all people named Ridley Scott, we are able to specify mapping to a string value from within the from operator, from operator's column definition. This acts as a filter. There's only one match. Let's see if I want to do.
And the interesting thing to me, yeah, it's going to say if you actually want the person's name as well, you have to explicitly put that in there.
There's no like star.
I think there might be now. Try star and see if it works in this syntax. It works in SQL. There you go.
Oh, hey, look at that. It works. Wow. That was pleasant.
Yeah, that was something that's been added fairly recently, I think, because you could do it in the SQL, but you couldn't do it in the XTQL.
This is cool because this is essentially like in XTDB1, the entity API, where you're like, I want, because there's one thing I always kind of bother me about Datomic is that you're like, how do you actually get like the whole thing you put in? And there is now the pull syntax. I know there's a way to do it, but the entity was a way to do it with XTDB1. So this is basically a similar way. You just do star.
Site that they publish information to the blind. They have lost.
Well, let's see.
that because the
Alternatively, we can construct a pipeline of operators to perform the same task using an explicit where operation.
it's Los Alamos.
I'm gonna,
Los Alamos managed to hide away a lot of their.
I can. A where operator. To filter the source relationship. Equality expression is used within the where operator. So this is the same thing. We can do star again. Nice. Okay. That's pretty cool. Makes sense. And we can't like execute this. Yeah, we don't.
No, it's not a Honey SQL DSL builder.
Oh,
Even though they've used the thread, that's just their pipeline operator.
it's like pseudo. I mean, I guess data log queries have always been quoted, so we should be used to it by now. I should be used to it by now. I don't know if I am. Two results are equivalent execution plans. We want to avoid unnecessary processing and return the person name column in the output relation. We can use a final return to restrict the output.
So the from needs
I
both
see.
person name and XTID so that you can match on person name in the where clause. But if you really only want the XTID back, you can just say, well, I'll return this subset of columns.
So if you don't put the person name in the from,
Yeah,
not all
then you
variables
can't match on it on the
expression or
where.
scope. Ah, oh, interesting. Okay. So let's try not revealing solutions right away. Find the IDs and titles of movies in the database. So the IDs and titles of movies in the database.
So we're going to want from movies.
Movies, IDs and titles. I do like how XTDB 1 seemed to come back with vectors of vectors. Like it seemed like it was unnecessarily nested, the results from the query. And I feel like this is the level of nesting that I would expect from a query is just one level, you know? Because I think sometimes it would return, because it wouldn't return maps by, this seems to return maps by default, like a list of maps or collection of maps. And I think XTDB1 would generally return you a vector of vectors.
Yeah, there was like you always unpack an extra vector, like,
Yeah, I
and
think there was
you always forget about it, regardless of how many times you do it.
So find the name of all people in the database. Persons, all the people. What was it? Person name. Find the IDs of movies made in 1987. Movies. So then we need a where?
Or you could have a map with movie year being 1987.
Oh, like, let's do it that way. Movie year 1987. Or that?
Yeah, I think that'll work. There we go.
Movie title. Maybe Star Wars what I wanted, just to make sure there's 1978 or 1987 is in there. Yep. Okay. Oh, and there's the where version. All right, so relational composition. XTQL provides the rel source operator, which can be used to construct and manipulate temporary in-memory relation. This relation can be used in a pipeline the exact same way a stored relation represented using from. Similarly, the columns can be returned explicitly. Interesting. So this is just like, here's some random data that I wanna match against temporarily, huh? You star to retrieve a nested representation of all columns in the relation. Note the use of star is rarely appropriate for production queries, but certainly useful when exploring data. Let's run a previous query over a subset of the original data, which is not resubmitted to the database. Okay.
So I guess this allows you to use XTDB's query against data you have in memory, that's kind of an interesting way to go about things, because you could do a query to get back your initial data, and then you could run queries on that, and it wouldn't hit the database, it would just use the query engine on the data.
I guess this also solves the question of one of the things you could do with XTDB1 was you could give it like pretend this data is also in the database and run the query. Like you could, it was like speculative query. I forget what the word was. I might also be thinking of something from Datomic, but there was some way of being like, here's some extra data that I want to put in the database, but I want to just make sure, pretend like it's in there and run a query across it. So although this is not the person's relation, like the person's table. This is just like a separate one.
Right. So this is just some raw data that's not connected to the database at all.
Yeah.
Yeah.
Oh yeah, here you go. Query avoids retrieving any of the stored data altogether and is completely disconnected from the person's table. Okay. Unnest. Nested values can be expressed as regular columns using the unnest operator, which returns a cross-join relation. Okay. So unnest my item from my list. So it makes 3 of them with 1 entry from each of, I understand it duplicates my list also. Oh, I guess you can do the unnest and then you can use this to join it with another table, like how we have the cast. Like if we unnest the cast, then we can join it with person and get
Yeah.
people in a movie. Using the with operator, which extends the previous relation with it. Well, the previous relation with additional columns, specific nested values can be accessed using dot and nth operators. So there's a relation that has one document with 2 columns or 2 attributes, I guess. Nth
My list is a vector.
A vector. So this is taking that vector and putting it as a top level key. And then
So it's
my
taking
item.
the first item from my list and adding in my item. And then it's adding in my val with the bar element of my item. So
it's
this is
drilling in
allowing
and
you to
putting
drill
things.
into a key within that.
And then it appears as a my item and my val are top level. So it's a way of pulling those out. That's pretty cool. You can go that far down. And it's not just, you know, oh, you can do like a flat list of IDs, but this is actually like digging farther into that data to put it at the top level. So you could have a rather arbitrarily nested set of data and still be able to pull it up and join it across, it's pretty interesting. Unification. Joins in XTQL are most naturally specified using the unify operator. This combines multiple input relations based on the use of logic variables to represent and connect various columns. Within unify scope, all symbols represent logic variables rather than singular columns. They represent logic variables rather than singular columns. However, a logic variable may take the name of a real column, which creates an implicit binding. So we have unify from movies, unnest p movie cast. So p is like a
So p is a logic variable.
logic variable, yes. And movie cast, because it has the same name. Oh yeah, well it does because it unnest we already got.
Implicitly bound.
From persons, and it does a filter based on XTID on that. It grabs it. Oh, because it's it's just a list of IDs. So P is an ID essentially.
Yeah.
Person name, return person name. So this is everyone in Lethal Weapon. I guess I could have read this paragraph too. We want to find out who started Lethal Weapon. We will need to process two source relations for this, both movies and persons, and to see this, we need to embed two from operators within Unify, which itself returns a relation. However, this requires introducing our first username logic variable. We choose P, and we need to unnest the stored vector or the nested vector of movie-cast. So if we don't have so it'll have all of the, it'll have the movie cast, it'll have the P and the person name. Working. What if we want the ID too? We do person, no, XTID. Yes, I wonder what happens if you have XTID up here. Oh,
You get an empty result because if it tries to match the two XTIDs, they won't match.
oh yes, there are logic variables also.
Mhm.
Wonder how you can alias. I bet you can. Hope you can. Okay, logic variables can be used, referenced such as required, as much as required across many clauses within a single unified scope. Think unification is similar to simultaneous equations in mathematics, a logical variable that connects multiple underlying columns, forces the database to solve the query. Yes, like just like you said, because it's bound, now it must be the same, and that's why the result is 0. Implicit binding will reuse the underlying column name for the logic variable, but you can always add an explicit binding instead. Movie cast C if you struggle with verbosity of the logic variables caused by the long underlying column names.
And that's sort of aliasing a column as a different logic variable.
So I could do,
So if you added to that first from, if you added a map from xt/id to, I don't know, X or movie ID, yeah, that works. There you go. And does that
oh,
work
I
now?
need to, yeah, I need to undo my return. There you go.
Yeah, and there's your movie ID.
So that's how you alias a column is by, because it's basically instead of saying if there's a literal there, then it's like a where because it's matching against it, and this
Mhm.
is basically saying whatever that is, so it matches on any of them.
Yeah, because in the second from clause, you've actually got that. You've got XTID is bound
Oh,
to
right here.
P, and it's unifying the P from the unnest.
And that's why it's called unify and not join, because it's a mathematical thing. All right.
And that's
Find
more
movie
like
titles
data
made
log,
in
isn't it?
19
Because that
Yes.
unifies a whole bunch of things. Yeah.
I think that was that's something that I always had to relearn every time I tried using data log was because it was I mean in a sense like all the where clauses in a SQL statement have to be true. So but you can kind of treat them one by one. There's not I don't know. It's a different approach to finding to matching data together, I guess. All right, so find movie titles made in 1985. Wait, did we already have this one? Movie year 1985. Oh, right, we need, that's the ID. And that's the title. Okay, so what year was Alien released? All right,
From
I'm not gonna solve it.
movies.
I will type and someone else talks.
From movies. Where a map of movie title is Alien.
Oops, not that one. Movie title.
Then we want
And-
to return movie year.
All right. Who directed RoboCop? Okay. So we need to unify from movies. Who directed RoboCop? Okay, so we need the movie RoboCop, which would be like this. Who directed it? What's the schema again?
It's
Director. Ooh, don't go too far. So then with from, we also need from persons. Who directed it, right? We want person name. So what do we want here?
so in the
Mm.
first from you want movie director instead of XTID,
Movie director.
and then in the second one you want to have a map of XTID that will unify against movie director.
I like that. And then we want person name.
Yes, you've got person name. Just to say, if you run that on its own, you'll get, I think, the whole thing back, just to check. Or will it? Yeah, and so
Oh, there
we
you
just want person name back. Nice.
Return person.
They're very readable queries.
Yeah, I think looking at the data though, like when I see that, I want the like to run it and get the data out because I'm used to that from Honey.
Right.
But we don't need that because the reason why I need to run that a lot with Honey SQL is because I need to make sure that the SQL that I'm generating is correct. And in this case, there is no other level. It's just this is it.
Yeah. And
Yeah, very readable.
there's a query template function, I think, in XT2 that allows you to construct these with placeholders in to substitute data in.
Oh, okay. So instead of RoboCop, it's like some template variable,
I think, yeah,
like a
I'd have to go,
placeholder.
you have to go look at the docs for that.
So they replace this in operator. So that was a weird part about the Atomic where you just like add in
Yeah.
and then like you like pass it as an extra arguments to queries. It was always hard for me. Kind of not hard but unnatural.
Yeah, we're so used to those question marks, you know. All right, so find directors who have directed Arnold Schwarzenegger in a movie. Um, so we're
I
gonna
guess we
definitely need to
need
unify. Yeah,
XTID from what people, not person. Person name.
persons.
Yeah, person
And we
name.
want
Arnold Schwarzenegger.
okay, so we got that. What's next?
And then we have its XTID. So now we need to find movies where he was
Where
starring.
he was in the cast?
Yeah, in the cast from movies. Fine. what is the operator for cast? Can you just say movie cast XTID?
Yeah, you just want the movie cast back, and then you'll want to unnest that to get an ID and unify that against the ID from the Arnold Schwarzenegger person lookup.
The movie cast. Okay, so we've got the movie. So now we have the movies that he's in. We want movie cast and movie director. And then we want from persons again.
Right, sorry, I misread the question.
Yeah.
Yeah,
And now from persons we need director.
yeah.
XTID movie director.
Oh, we don't need the movie cast at all, do we? Sorry, I misread the question.
Well, we do need
Well,
it
we still need to
because we need
filter
because we
by
need to
movie
unify.
cast.
We need to move it, do it by
Oh, I'm with you now.
the
Yes, sorry.
Schwarzenegger is in the
Schwarzenegger has to be in
cast.
the cast.
Yeah.
Yes, of course.
And here we have person name, and then we're gonna call this the director. And return.
So nothing has unified Arnold's name into the cast yet, though.
Yeah.
So
So
if you,
XTID.
yeah, so if you make that a map from :XTID to P,
Like that.
:XTID,
Oh, yes.
that should work. No,
Ah, I love how structural editing works in this. 'Cause I can just move them around.
mm,
So we match cast to P, we make director to director, and we match P with Arnold.
yeah. And so now if, yeah, okay.
And James Cameron directed him twice.
So if you were to return movie title,
Turn.
to
Let's
return,
see.
yeah, you'll need movie title.
Oh, not there.
Not there, no. From movies. And then in the return, and we'll see which 2 movies Cameron directed him in. Huh. Yeah, of course, Terminator and Terminator 2.
Cool.
So they called him Arnie, but everything else is pretty much. Yeah, and I renamed him director. Although that wasn't necessary. Okay. So I guess if we want to dedupe the directors, we can just use a Clojure code at that point. Although maybe there's a aggregate function. Count distinct. Oh, those are numeric aggregate. Well, let's leave it at that. All right. Ready for the next bit? How we doing? All good? Okay. Look at this query. Okay, so from persons, XTID Sylvester. So we're getting Sylvester Stallone. from the movies, the cast, and the title. Unnest, Sylvester movie cast, return movie title. So this is all the movies Sylvester Stallone's been in. Great if we could reuse this query to find, here's our templating. Movie titles for any actor, not just for Sylvester Stallone. This is possible using parameters, which are supplied in a map as a map under args key to the options map of XTQ. Then queries parameters can be referenced using the dollar symbol. We'll get Sylvester Stallone, so if we go Arnie. There you go. Pass any number of input parameters to a query. These parameters can be used for relations as well as a full range of value types. For example, you say you want to have the vector James Cameron, Arnold Schwarzenegger, and you want to use this as input parameter to find all movies where those two people collaborated. First, outside of XTQL, you would need to reshape the vector into a value relation, a vector of maps with named columns. And refer to it via the rel source operator. Wow. Because James Cameron and Arnold Schwarzenegger have a relationship, like you're trying to find a relationship in the data, you have to make a relationship, like a pseudo relationship, so that you can then express it to the query engine. Terminator and Terminator 2.
It's very cool.
Remember that? Yeah, yeah. I agree. So it's not templating. This is a different way of getting stuff in there. The templating, I think, is still something else.
Yes,
Say you want to find a
it's
movie.
part of the
Okay.
client API. I was just trying to find it. Just took me a while. I'll post a link.
Oh, it's like macro templating.
Kind of.
Mhm.
It'll be interesting to see how this works out in practice with large queries, because I'm kind of used to building complex SQL queries piecemeal with a whole bunch of little functions using Honey SQL.
Yeah.
But this isn't quite the same, because this lets you build one query with a bunch of conditional parts in, but you have to have them inlined as if you were doing a macro expansion.
Yeah. Yeah. I agree. It's interesting challenge. I haven't actually used Honey SQL in a production code. I've only used it in like database exploration code, and I've gotten pretty used to making functions that have like a lot of dynamic building and stuff that I press parameters in, and I can do different kinds of queries. And so yeah, I wonder how that would be possible with XT. All right, so say you want to find all the movies directed by either James Cameron or Ridley Scott, you can simply add an additional row to the input relation. Oh, yeah, okay. Well, who was our other? director here. Let's go with Mark Lester. So there's them. We add Mark Lester. We get yeah, Commando. All right, here we go. Now let's consider an input relation with column movie title and box office earnings. All right. Combine this data with the data in our database to find box office earnings for a particular director. So we have a relation that has the movie title and the box office earnings. So we just take the data and just put it in as the oh, here, earnings and director. Oh, here, there's director. We use a relation from persons where the director is there and make a logic variable. From movies where movie title is matched and movie director. So that matches those two. And we return movie title and box office earnings. Let's see. Oh. I didn't pick a movie that the movies don't have.
You don't have director in the rel. Oh, wait a minute. Sorry. Args, dollar. Did Cameron
Gotta
not
find it.
direct those?
Maybe not. So let's see, we can just add one in here and say, because I know we did Terminator. I thought he did Terminator, right?
Maybe just Terminator 2.
Oh, it's the Terminator. Gotta have the movie name be the correct title there. But there you go. So then I guess the summing up is left as an exercise for the Clojure code. Although there is a
Is an aggregate function sum? Numeric
some.
sum, yeah.
Although where do aggregates go? Do they come like here?
In return, probably.
I don't think. Oh, here.
What
Maybe we
what
can
does the
do.
doc say for it?
They have reference, but not.
Oh, and aggregate close. So you need to do aggregate close.
Trying to
It's
see
the
if
very
we can
first
find an
line.
example. Oh,
Aggregate
Right.
functions can be used with aggregate close.
Yeah. There's an
So
example.
similar to Unify, probably. Before return, just put aggregate, and then you can.
So
so if we add the other movie that we know that James Cameron did. Make it some other number. Then we say aggregate. What was it again? Let me just copy this whole thing. We want total is sum of box office earnings, maybe. We can
The-
move.
You're going to be aggregating over something else. You've got to be aggregating over something in the Unify. Because you'll say that total is the sum of box office earnings, but what are you aggregating over?
Like what am I grouping by?
Yeah. So that needs to be either by director or movie title or something.
You mean in this map here?
No, in the aggregate line,
Mm-hmm.
because the map will introduce total to be the sum of the box office earnings, but you have to aggregate over something for it to do that. See here, it's aggregating over customer ID and customer name, which are logic variables from
I see. I want to do on director then. No. Yeah, our director. We want to aggregate on the director.
Yeah, although you've only got one director, so. Do you want to
Not all
do
variables.
P instead of $director? Oh, you're not inside the Unify. That's yeah. So you actually have to use
so
a
I
real
have to
column
say,
name.
let's see. So person name director.
So you've got a
X.
column person name. You could aggregate over person name. You don't need to add anything there. You've already got the person name column.
That.
It says, nope, that's still not valid. Huh.
I wonder if we do XTID director ID. I wonder was tripping up on that.
It's interesting.
Okay, so that looks like the right.
Huh.
So if it was $10 and $20, should end up being 30. Yeah.
That's interesting because the example does look like it could aggregate directly on column names. Oh, because the from persons isn't pulling the person name.
It's matching.
Right, it's matching on it, it's not pulling it. So if you remove the
Like
director
this.
ID thing there and put person name so it's returned and then aggregate on person name.
Person name.
See if I've understood the example correctly. The answer is yes.
We have a
Okay.
winner.
Okay. Yeah, that thing where you can match on a column but it doesn't return it is weird.
Yeah, and not being able to use $director, but $director only exists in this relation. It exists in here because it's part of this relation.
No, $director is coming from the args, so
you're right.
that
But
should
yeah,
exist.
why can't I use $?
Maybe aggregate only works on column names and doesn't do substitutions. So there may be limited context where it does substitutions.
Yeah, maybe only in the Unify. Well, that's cool. I feel like we did a little farther than the exercises presented to us.
Yeah.
All right, so find movie title by year. All right, I'm only typing. Someone else has to say something.
Come on, someone else. All right, from movies. We want to get movie title back. We want to match movie year on dollar year.
Die Hard and Rambo. Yeah, this is exactly what you just said. I would have assumed movie year would come out because movie year was in the where clause, so to speak.
Yeah.
I guess that's one benefits to using the other form. This one where equals year movie year. Now this should return the same thing, but because it's separate, there's no like I selected on it, but it didn't come out, thing. Oh. All right, so given a list of movie titles, find the title and year that movie was released.
So we're gonna have to have a rel, a unify and a rel.
Rel. Title rel. And then what do you put in
Column
there?
we want is title.
Like that?
Yeah.
Okay.
Then
Find the title and
from
year.
movies, we're gonna want movie year and movie title. And then where title equals movie title. That I think that's going to
I don't
fail
think
because
that's
the
gonna
where is
work.
outside the scope of the unify. So I don't think you need the pipeline. I think you just want the where inside the unify.
Oh, you mean the map version?
No. I was going to say with
Oh.
the where clause, or does where clause go
Like-
inside the unify or outside? Because you're going to be using logic variables in the where. That's why I was thinking it had to be inside the scope of unify.
Yeah, I thought so too. So would it be like here, like that?
That's what I'm thinking. Where equal title movie title. Because that's going to bind to the logic variable.
But I think Unify has to only have sources. So let's Oh, interesting. I guess that's the same thing up here. Unify, because this one, though I thought it's like it sticks the from inside the where, so to speak.
Well, it doesn't, because the from is pulling it's doing the things in order. Yeah, I suppose you could think of it like putting the from inside, but the where is a filter on the data it's already got. And the unify, I guess, is acting as a sort of pipeline too then.
Yeah. That is a little bit surprising. But we could also do it the other way where we have a map. Maybe title. Yeah. Cool. All right. Final movie, all movie titles where the actor and the director have worked together. Did we just do this one above?
Well, this is with, you've got to find where they work together. So you've got to find all the, from persons based on the director name and from persons based on unnesting the cast from all movies.
We want unify movies,
Mm-hmm. And then we want to get
movie
cast and director.
director, and then we want from persons. Sorry, go ahead.
Yep, from persons based on the director. So that's person.
Movie director.
And okay, so we're only looking for the titles of the movies. Okay, and then we're going to need to unnest the cast to something. Oh, good point. Yeah, we need that.
Unnest. Person in movie cast. And then we need person down here. So this is the
Right, and then you're
actor.
gonna need to pull an alias of the person name out of. No, we don't, because we only need the title, don't we? We don't care about any columns from persons. So no, I think that's enough.
Oh, we need to add the rel
Oh, sorry.
director actor rel director oops and actor. And
That's gonna be the names of the persons. So yeah, so we're gonna have to have in the first from persons for the director, you're gonna have to have a match on person
okay.
name to director.
And then in
Second
this one, person name is to, what was that?
actor.
Actor.
Interesting.
I think that's, oh, that's too much information, but that's fine because we can. So where does the return go?
That's gonna go outside the unify, isn't it?
Return movie title. Oof. There you go.
Hmm. Taking me back to my prologue days a bit. Unification.
Oh, true, yeah. Unfortunately, I never had the opportunity to take prologue in any educational format.
I worked at a company that had a fairly large prologue team and was developing a lot of software in prologue. I didn't work on that team. I worked on a different team where we were working with transmuters.
Oh,
They hired me originally because they were looking for someone who could write a compiler from actuarial language, which is a sort of math symbol language, to parallel C that ran on the transmuters. And that's, once I got in there, I found they also had a big prologue team, which I was quite fascinated by.
wow. That's for smart people. I'll stay down here with practical Clojure. Although I guess we're getting into
Yeah, unification.
complicated things. Yeah. Okay. All right. Write a query that, given an actor name and relation with a movie title rating, finds the movie title and corresponding rating for which that actor was a cast member. Was rating in the
No, so rating is a new thing
No.
that's being provided in the REL. Let's see.
find movie titles for which that actor was a cast member? Okay. So we're pretty familiar with making a nesting movie cast. So we go from movies, movie cast, nest, the movie cast. And I guess if we really were doing data log, this would be P question mark or something like that, right? Then they, or is it question mark P? I forget.
Yeah, I think it's question mark P. But yeah, I don't know whether it allows that. I wonder if it would allow a variable that begins with question mark.
Seems to work.
There you go. I guess because it's a valid Clojure identifier.
Yes. Thank you, Clojure. Thank you, Rich. From
So we need persons to
Persons.
match the name. Oh, so we match on the ID. Yeah, ID against P, you're right. And then the person name against. Oh, because we need a rel in there, don't we?
Rel title rating rel, and that comes out with title and rating. So then we need to match on movie title. And then
Person name has to match. Wait.
Find
So
the movie
person name
titles
is
and corresponding rating.
So when we do the from persons on the cast, we want person name to match dollar name.
Oh, I didn't even see that there was name here. So we want, sorry, we're gonna need to match the name, right?
Yeah.
Person name.
Yeah, dollar name, that's right. And
An actor and relation. Find the movie titles. So movie title.
although, yeah.
And corresponding rating.
In which case the return has to be inside the unify.
I think rating return movie return can't be inside.
Right.
But I don't think this is gonna work because rating is not expressed.
Oh no, rating. Do it without the return and see what we get back, because I bet we get the rating back because it's one of the things in the RAL. No?
I think I might have constricted things too much because there's nothing matched.
But given an actor in a relation with the movie title rating, find the movie titles and corresponding rating for which that actor was a cast member. But if the title is Die Hard, Mel Gibson wasn't in Die Hard, was he?
He was.
Was he?
I think so.
Bruce Willis was in Die Hard.
Ah. So that was the problem, is that we had a movie that wasn't, well, unless we find a movie that Mel Gibson was in and give it a rating.
That's kind of weird because you'd have to have a whole bunch of movie titles and ratings to make that work.
Yeah. Okay, so look at that.
Yeah.
So rating, it does work. We get
Okay.
rating out here because it's like this is like a table. Yeah.
Yeah.
What's the answer here? Ah, well, there we go. We had the rel, we had movies.
Yeah.
And then nest, yeah. Return title and rating. Oh, I guess yeah, we could just use title. We didn't have to add the additional mapping.
Oh, right, yeah. Of course, I'm thinking of it as a logic variable, but it's just going to be a
Yeah.
column in there now from rel. Hmm.
So here's all the one Mel Gibson's been in. Oh yes, the Mad Max series.
I think some of those ratings are very generous.
They are historical. Cool. How are we feeling? Want to keep going or take a break? Go back
Well,
next time?
we're running up to 10 to 8.
Yeah. Much more do we got here? Expressions, generating columns. We only have expressions and generating columns. And that looks like a pretty short one. I think we can do expressions in 10 minutes.
Yeah.
All right, so expressions. So far, we've only been dealing with joining of data across relations and unnested columns using basic equality. We've not seen how to handle expressions like find movies released before 84. This is where expressions come in. Oh, okay, yeah. Greater than, or less than, rather. Like all of the functions and expressions, this use of less than reflects the standard SQL definition of behaviors. This is particularly important to keep in mind when creating such expressions that work across multiple types. So movies that were before 84. How about after 84? More of them. You can use any supported SQL function from the XTDB library. Oh, there's like, of course. String functions. Like. Wow. For person name starts with M. Back to Mel Gibson. All right, so find movies older than a certain year. Let's see. So movies. Movie title. Can I just do, what was it? Where? Where? Older than a certain year.
You'll need movie year
Oh.
in the from. And that will give us back the list of movies and years.
So are you they? Uh-oh. Oh.
There aren't any really old movies in there.
Oh, there are. So it's actually inclusive. That was what I missed.
Oh, inclusive, yes, older than a certain year inclusive.
Find actors older than Danny Glover.
Hmm.
All right. Your turn, Sean.
Do we know, have we got person age or something?
Where are we here? Oh, it's folded.
Ah, person born. Okay. So
Oh,
we can compare two person birth dates, is that it? I guess. So we want to
sure.
find okay, so yeah. So let's find, let's see, from persons
Oh,
let's-
older than Danny Glover.
right.
Okay,
So
so
we
we
want
need
to
Danny
find who
Glover
Danny
first.
Glover is. So we want to match on person name to Danny Glover. And we want person born.
From there. Okay.
And then we also want from persons, and then we'll want a map from person born to other, so that we can compare the two other, oh, not actor, so the other date, whatever, yeah. And
Otherborn.
otherborn, yeah. Naming's hard.
It is.
And let's see, we're going to need where otherborn is less than person born.
This one should be in a
Are you going to do it
in the
in the
map,
hogs?
right?
Oh, yes, sorry.
Sorry, what was the next bit?
So now we're going to need a where otherborn is less than person born. I suppose we could have aliased that to Danny Birth or something.
We should do Danny Born.
Yeah. And let's see, what else are we going to need here? Because we want to print out those names. So yeah, so from the second from, we're going to need person name.
Okay.
And then we'll want to return person name. Although that'll just return everything if we do it the way it is.
Let's just try that.
So Danny was born in 46, July 46. And all the others were born before that. So it's good.
Oh, I see. You can see Danny Born right there. You don't have to.
Right, because it's in the data results.
So then if we want to just return person name.
Yeah.
Cool. How about younger than Danny?
Yeah.
A little younger.
And I guess if we were going to do it
Cool.
in the same way as the other stuff there, we'd want arg's name Danny Glover and have dollar name in that first one.
So then we can do younger than Joe Pesci.
Mm-hmm. It's older than, but yeah.
Cool.
Mm.
Very nifty. All right, last one. Find movies newer than year that have a rating higher than this one specified. Okay, I'm gonna go up here and grab this. Oh,
They do give us a couple of movies and ratings, and one of them's going to be higher and one of them's going to be lower.
the lights went out. It means 8 o'clock. Sorry, what were you saying?
So they've given us a couple of movies. I don't know whether that's going to be enough for movies that were made in 1990 or later that also have a rating of greater than dollar rating. So we're definitely going to need a Unify. We're definitely going to need a REL.
Title, rating, rel.
And we'll get title and rating out of that. And then
Okay.
from movies, match on movie title to the title. And we want movie year. And where, what do they want? They want movies newer than year inclusive. So the movie year has to be greater than or equal to dollar year. So yeah, less than or equal year, movie year.
Okay.
And we also want a where clause for rating
Higher.
greater than dollar.
Okay.
Let's see. Yeah, dollar rating. If the rating, that's got the supplied one. Let's, yeah, there we go. Yeah, I think that's enough to do it, isn't it?
Braveheart.
Yep.
Now we go less than
And we
the
should
lower
get
rating.
too. Yeah. And I bet if we dumped that whole block of movies in from above, that rel, yeah.
Oh, where are we going?
Let's see how many of those we pick up. Just those two, they've already done it for us. So we can change the year.
In 1980. All the ratings are higher. How about higher than a 6? Let's get Mad Max in there. Mad Max. At least a couple of them. All right, let's see what they did. Oh, they have. Oh, so you can just do the two where clauses right in there.
So it's an implicit and. Oh, they've also renamed the rating to a logic variable in the rel. I guess that makes sense, doesn't it?
Oh, because you have rating and rating.
Yeah, which does look a little odd. But
So
it
this would
works.
be title and movie rating.
No, because it's called rating in the hash map.
Oh, so you have
So you'd
to,
have
we can
you have to use
rename it,
rating.
we just need to get.
Hmm? Right, yeah. Yeah, now we see it as movie rating in the result.
I wonder if I can do movie slash rating. I assume I can.
As long as it doesn't coincide with the column name, it should work, I guess. Yeah, there we go. Movie rating. Nice.
Cool. Lastly, generating columns. Questions means transform data or return it via adding columns using with. The new columns or with the next operator in a pipeline or additional columns in a unify scope. Extract.
So that must be a temporal function. I have to say it's not one I'm familiar. Oh yeah, extract field from data.
Huh. Cool.
I seem to recall there was some muttering about Postgres adding a whole bunch of functions, and they were saying that, well, we'll probably add some of the Postgres stuff because Postgres is almost a standard.
Yes, I agree. All right. So Tina Turner is 85.
Huh.
Oh, current date.
Yeah. Must be, there we go. Lots of stuff about current time.
Oh yeah, so that's the now, like
Right.
in Postgres.
Yeah. Current date, current timestamp. Goodness.
Cool. All right. Well, that was
Brilliant.
really very interesting. I feel like I want to just like with XTDB, I want to actually try using it now. Not solve little puzzles, but I want to actually try using it for real. But it feels like it's like it feels, even though I know it's columnar, I feel like there's still entities back in there, like, the
Yeah.
whole documents.
And it still also feels quite SQL-y.
Yeah, I agree.
Because the from clause is kind of select a set of columns from a table, although it's got that implicit where in it. But then the joins are implicit with the unifies. And I think I read it's got a join clause as well. So there's an explicit join as well. Where did I see that? Yeah. Oh, I see. There's unify is the join, and then there's a left join operator. And they say there's a join operator as well.
Without removes columns for the ongoing query.
Oh,
Interesting. instead of, so that's cool because instead of specifying what you want, you can specify what you don't want.
Hmm.
Everyone, except for you.
Very cool.
Cool. All right. Well, thank you all for chatting and hanging out.
And thank you for driving.
Yeah, no problem. Glad to do it. That was fun. Always good to learn.
Thanks to you both for walking through that. Thanks for prepping your environment, Nate. It was nice to see the evaluations. That was super helpful.
Yeah.
Yeah,
Yeah, that was really helpful.
being able to play with different things, different evaluations. Yeah. If it ain't a REPL, it ain't programming. All
Any
right.
idea what we're going to be doing next month? Any
We will
topics
be
suggested?
collaboratively creating an application using XTDB to. Just kidding. Speaking of Peter, I don't remember how to pronounce his last name. The guy who did Nippy. He has a new library out called Temple, I think, and it's got a lot of encryption stuff.
Hmm.
Like it's supposedly like a, you know, there's a high level interface so you can do like some higher. That might be a fun one to explore. Basically, in this format, we can basically pick any language. We can pick Honey SQL and go through that one.
True.
That would be, although it'd be way too long because we'd have to read all the documentation. That would take too long.
There is a lot of documentation. It's true.
Yes, that's how you know it's a core field library, is it's well documented.
Thank you.
But yeah, definitely open for any suggestions.
Mhm.
So you can think of some.
Cool. I'll look around.
But-
Yeah.
Cool then. All right. Well then, everyone have a good February. February. See you in March.
Thank you, folks. See you all next month. We'll see you online before that, I expect.
Absolutely. Thank you. All right. Adios.
Have a good one, everybody.
Bye.